Good morning or good evening. I don't know when you are watching this, but it doesn't really matter because we are going to talk about something that happens every single morning, regardless of the time you wake up. You walk into the bathroom, you are a bit groggy, you look into the mirror to brush your teeth, and there you are. You pick up the toothbrush with your right hand, but the fellow in the mirror, he picks up the toothbrush with his left hand. You wink your right eye, he winks his left eye. And you say to yourself, yes, mirrors reverse left and right. It seems obvious. It is common sense. Everyone knows this. But wait a minute. Stop right there. Why? Why does the mirror reverse left and right? Why doesn't it reverse up and down? Think about it. You are standing there. Your head is up, your feet are down. The image in the mirror also has the head up and the feet down. The vertical direction is fine, it is preserved, but the horizontal direction, swapped. Why is the mirror so asymmetrical? How does the mirror know to flip the horizontal axis but leave the vertical axis alone? Is the mirror built with a special horizontal flipping chemical? If you were to lie down on the floor, so your head is to the left and your feet are to the right, does the mirror get confused? No. Now, the image has the head to the left and feet to the right. But if you wave your top hand, the right one, the mirror waves its bottom hand, it still flips you relative to your own axis. This is a terrible puzzle. It bothers people. It bothered me for a long time, because if you think about it, a mirror is just a flat sheet of glass with some silver on the back. It is perfectly symmetrical. It doesn't know up from down or left from right. Gravity acts downwards, sure, but light doesn't care about gravity in the bathroom. Light goes straight. So, if the mirror is symmetrical and the light is symmetrical, why is the reflection asymmetrical? Why the preference for left and right? The answer is going to bother you. It is going to itch at your brain a little bit. The answer is, the mirror does not reverse left and right. It never did. It doesn't touch left and right. You are the one doing the reversing. It is all in your head. Stay with me. We are going to find out how you are tricking yourself. If you want to understand how the universe actually works, not just how it looks, but how it works, hit that subscribe button. We are going to take things apart and see what makes them tick. Let's find things out together. You see, the problem with common sense is that it is usually just a collection of prejudices we acquired by age 18. We trust our eyes too much. We say, I saw it with my own eyes, as if that settles the argument. But the eyes are just lenses. The brain is the one doing the seeing, and the brain is full of old habits. Let's do a very simple experiment. I want you to imagine you are holding a book, a text. Hold it up to the mirror. You can't read it. The letters are all backwards. Aha! You say, see, left and right are swapped. But are they? Look closely. The top of the letter A is still at the top. The bottom of the page is still at the bottom. The left side of the book, the physical left side of the paper you are holding, is reflected on the left side of the mirror. And the right side of the book is on the right side of the mirror. If you take your finger and touch the left side of the mirror frame, the reflection touches the same side. There is no crossover. The light goes straight from your finger to the glass and bounces straight back. It doesn't do a loop-de-loop. It doesn't crisscross. So, if the left is on the left, and the right is on the right, and the up is on the up, and the down is on the down, where did the reversal come from? It comes from depth. It comes from the front to back direction. That is the only thing the mirror changes. Imagine I have a very flexible rubber mask of my own face, and I hold it in front of me. The nose is pointing at the mirror. The light travels from the tip of the nose, hits the glass, and comes back. It travels a very short distance. Now look at the ears on the mask. They are further back. The light has to travel further to hit the glass and come back. The mirror takes the object and squashes it flat against the glass, but it preserves the order of depth, just reversed. The nose, which was pointing forward into the room, is now pointing backward out of the mirror. Think of a glove, a right-handed glove. You have seen these. They have a thumb on one side. If you could take that glove and turn it inside out, pull the fingers through the wrist, what do you have? You have a left-handed glove. By reversing the inside to outside direction, the thickness, the depth, you change the handedness of the object. That is what a mirror does. It turns space inside out along the direction you are looking. It squashes the z-axis. So why do we insist on saying it swaps left and right? Why don't we say, oh, look, I am inside out? This is where psychology crashes into physics. It is a psychological illusion caused by our symmetry. Human beings are bilaterally symmetrical. We are roughly the same on the left and the right. One ear here, one ear there. One arm here, one arm there. But we are not symmetrical front to back. We have a nose on the front and the back of our head on the back. We are not symmetrical up and down. Head on top, feet on bottom. When you look into that mirror, your brain instantly recognizes a pattern. That looks like a human being. And your brain asks a question, how would I have to move my body to look like that guy in the glass? Well, you can't just walk straight into the glass. You would have to turn around. You imagine yourself walking around behind the mirror and turning to face the front. Now, how do you turn around? Do you do a handstand? Do you rotate vertically, putting your head between your legs and flipping over? No, that's difficult. That's unnatural. You rotate horizontally. You walk around the chair. You spin 180 degrees around your vertical axis. When you imagine doing that, walking around to face yourself, your right hand swings around and ends up on the other side. Your left hand swings around and ends up on the right. So when you look at the reflection, you are mentally projecting yourself into that position by rotating horizontally. And because you rotated horizontally, the left and right are swapped in your imagination. You look at the image and say, hey, that guy is holding the brush in his left hand. Because if you had walked around there, it would be your left hand. But the mirror didn't do that rotation. You did. Let's prove it. Let's prove it is your brain making the mistake. Imagine you are sleeping. You are lying on a bed in front of a mirror. But let's say, for the sake of argument, that human beings were different. Imagine we didn't walk on feet. Imagine we were like rolling logs or rotisserie chickens. We never turn left or right. We only rotate by rolling on the floor. If you were a rolling log person and you looked in the mirror, your brain wouldn't imagine walking around the back. It would imagine rolling over. If you rolled over to face the mirror, your head would end up where your feet are. You would be upside down. If that were our biology, we would look in the mirror and scream, my goodness, mirrors reverse up and down. We would complain that the ceiling is on the floor. We wouldn't care about left and right. We interpret the reflection based on how we move. Since we move by turning left and right, we blame the mirror for swapping left and right. It is a fascinating thing, isn't it? We act as if the reflection is a real object, a real copy of us. But it isn't. It is a pseudoscalar. It is a mathematical object where one coordinate has been multiplied by -1. The depth coordinate becomes. Now, I want to take this deeper. I want to tell you about a time this actually mattered. Because you might think, okay, Richard, this is a nice parlor trick. It's just semantics. Who cares if it's depth or width? It's just a reflection, but it matters. It matters because it leads to one of the most profound questions in all of physics. Can the laws of nature tell the difference between left and right? This is a problem I wrestled with. It's called parity. Imagine we make radio contact with a Martian. We have never seen him. He has never seen us. We are talking over a very long distance telephone. We want to explain to him what we look like. We say we are 6 feet tall. He says, how big is a foot? We send him a signal of a hydrogen wavelength and say, it's this many wavelengths. Okay, he gets the size. We tell him we have a head on top and feet on the bottom. He says, which way is up? We say, away from the gravity of the planet. Okay, he gets up and down. Then we say, put your heart on the left side. And the Martian says, duh, which way is left? How do you tell him? You can't say, it's the side where your thumb is on the right because you haven't defined right. You can't say, it's the side the sun sets on because his planet might rotate the other way. You can't say, pick up a screw and turn it the way it goes in because threads are arbitrary. We made them that way. He might make left-handed screws. Is there any experiment, any physical phenomenon that looks different in a mirror than it does in real life? If the laws of physics are symmetrical If the universe doesn't care about left and right, then there is absolutely no way to explain left to the Martian. A movie of an experiment played in a mirror should look just as possible as the real movie. For a long time, we thought the answer was no. We thought nature was ambidextrous. Newton's laws work the same in a mirror. Gravity works the same. Electromagnetism works the same. If you watch billiard balls bouncing, and then you watch the reflection, you can't tell which is real. Both are physically possible. But then came the shock. There is a force called the weak force. It causes radioactive decay. It's what makes the sun burn. It's a subtle thing. And some brilliant people, Li and Yang, proposed that maybe, just maybe, the weak force is not symmetrical. Maybe it has a handedness. So Madame Wu did an experiment. She took some cobalt-60 atoms. She cooled them down to almost absolute zero so they wouldn't jiggle around. She put them in a magnetic field to line them up like little spinning tops. Now, imagine these atoms are spinning. Let's say they are spinning clockwise. When they decay, they shoot out an electron. The question is, do they shoot the electron up or down? If nature is symmetrical, they should shoot electrons up and down equally, 50-50. But that's not what happened. They found that the electrons preferred to go in one specific direction relative to the spin. They came out the south pole of the atom, essentially. This was a bombshell. It meant that if you put this experiment in a mirror, the reflection would look impossible. In the mirror, the atoms would appear to spin the other way, but the electrons would still come out the same way, which would violate the rule we just discovered. The mirror image of the cobalt-60 experiment does not happen in our universe. Nature distinguishes left from right. This means we can tell the Martian. We say, Mr. Martian, please build a cooling device, put in some cobalt, make the atoms spin, watch where the electrons go. The direction the electrons come out, we'll call that up. Now look at the way the atoms are spinning. The direction of the spin defines left and right relative to that up. And he would know exactly which side is left without ever seeing us. Unless the Martian is made of antimatter. Because it turns out, if you swap matter for antimatter, the rules flip again. If the Martian is made of anti-cobalt, his electrons, positrons would come out the other way. So if he follows our instructions and he is made of antimatter, he will get left wrong. He will build a machine that is a mirror image of ours. And this leads to a very practical piece of advice. If you ever meet that Martian and he invites you to shake hands and he extends his times left times hand, do not touch him, because if you touch him and he is made of antimatter, you will both annihilate in a giant explosion of gamma rays. But let's come back to the bathroom mirror. When you look in that mirror, you are seeing a world that is geometrically inverted. You are seeing a world where a right hand is a left hand. You are seeing a world where if you could step into it, you would arguably suffocate, because the proteins in your body, which are left-handed spirals, wouldn't be able to digest the right-handed food in the mirror world. Biology is chiral. Biology has a handedness. The molecules of life twist in a specific direction. If you were reflected, you might not be able to function biologically. The mirror shows you a world that is mathematically consistent, yet physically distinct from our own. It effectively creates a parity-inverted copy of space. But the reason you perceive it as a simple left-right swap is entirely because of your own symmetry. It is because you are a creature that is the same on both sides, but different front to back. If you were a jellyfish, perfectly round, you wouldn't have this confusion. You would look in the mirror and just see a jellyfish. You wouldn't think about left or right. If you were a car, you would look in the mirror and see a car driving the other way. We impose our own structure onto the interpretation of the physics. The physics is simple. Light bounces back. The geometry is simple. Z goes to minus Z. The confusion is biological. The confusion is human. And that is the beauty of it. We look at the world not as it is, but as we are. So tomorrow morning, when you go into that bathroom, catch yourself. Look at that person. Don't just see a reflection. See the light bouncing. See the depth collapsing and reversing. Visualize the nose squashing against the glass. And remind yourself, the world isn't flipping. You are just trying to turn yourself around to fit into it. The universe is a strange and wonderful place, full of puzzles and the most ordinary things. A glass of water, a grain of salt, a bathroom mirror. If you look deep enough, you find the weak force, you find parity violation, you find the structure of space itself. That is the fun of it. That is the kick. Thank you for listening. If this twisted your brain a little bit, good. That means it's working. Share this with a friend who needs to be confused, and I'll see you in the next one.